So here in this problem, we need to determine the equation of a circle whose center is having the coordinate 3, 4 and it is tangent to a line with the equation given by 5x plus 12y equals to 1. Now let's try to graphically understand the problem. So here we have a circle with center C and the coordinate of the center is 3, 4. Now there's a line whose equation is given by 5x plus 12y equals to 1. And this line is tangent to the circle, let's say at point A. We need to find out the equation of the circle. That means, in order to find out the equation of the circle, we'll need an information which is the radius of the circle. So our task will be to find the radius of the circle. What we'll do? We'll do a construction here. We'll drop a perpendicular from the center C to the line meeting it at point A. So CA is going to be perpendicular to the line. Now, we have the line given here. The equation of the line is given by 5x plus 12y equals to 1. What we'll do, we'll try to rewrite this equation in the slope-intercept form, which is y equals to mx plus c, and that's going to help us determine the value of the slope m. Now we can rewrite this as 12y equals to negative 5x plus 1. Dividing both sides by 12, we have y equals to negative 5 over 12 times x plus 1 over 12. So if we compare it, y equals to mx plus c, this gives us the slope m equals to negative 5 over 12. So the slope of the line 5x plus 12 y equals to 1 is negative 5 over 12. Now CA is perpendicular to the line. So if we consider the slope of that line, now slope of the perpendicular line or slope of CA, and we multiply it to the slope m, the product is going to be negative 1. Now that's a property of straight lines. That means two straight lines which are perpendicular to each other, then the product of their slope equals negative 1. Since we have the value of m, we can easily find out the slope of CA. The slope of line CA is going to be negative 1 over m. So m value is negative 5 over 12. So we get 12 over 5. So that is the slope of the line CA. Now what we can do, we can find out the equation of line CA. For this, we are going to use the 1-point form, 1-point slope form. 1-point slope form. So let's first specify what's the 1-point slope form. Suppose we have 1 point x1, y1. And through this point, let's say a line passes and we know the slope of that particular line. Then the equation of the line is given by y minus y1 equals to m times x minus x1. So in our case, our point x1, y1, that's nothing but 3, 4, which is the center C. And we have just now found out that the slope of this line m equals to 12 over 5. So the equation of that line is going to be y minus y1. So y1 corresponds to 4. This will be equals to 12 over 5, which is the slope, multiplied to x minus x1. x1 value is 3. So let's solve this. We are going to cross multiply with 5. So we get 5y minus 20 as equals to 12 times x minus 3 will give us 12x minus 36, which gives us the value. Let's write as 12x minus 5y equals to 16. So this is the equation of line CA. Right, which is the perpendicular line. Now we have two lines. We have the equation of the new line CA that we obtained just now, and we have the original line 5x plus 12y equals to 1. If we solve those two lines, we are going to get the common intersection point. So this is going to give us the intersection point A that becomes the coordinate of the point which the line touches the circle. Fine. So let's try to solve this two equations. So where 5x plus 12y equals to 1. 5x plus 12y equals to 1. That's the equation of, this is the equation of line CA, and this is the line that is provided to us, right? So you can use either the elimination method or in the substitution method to find out the values of x and y. That I'm leaving as an exercise for you to try out. I'll straight away note down the value. So x comes out to be 197 over 169. And the value comes out, or value of y comes out to be negative 68 over 169. So we have obtained the coordinate of point A, which is 197 over 169. That's the x coordinate, and the y coordinate is negative 68 over 169. Now we have coordinate of point A. We are already provided with the coordinate of point C. Now we can use the distance formula to obtain the value of r. So r will be equals to, so here we're using the distance formula. So within the square root, we'll have to first take the difference of the x coordinate. So that's 3 minus 197 over 169, and we're going to square this difference and add it to the square of the difference of the y coordinate. So that's going to be 4. We have minus of minus 68, so that gives us positive 68 over 169. So that the radius comes out to be equals to 62 over 13. So now we have the information regarding the radius of the circle as well. Since we have the center point, the coordinate of the center 3, 4, the radius of the circle, we can use the standard form of a circle to obtain the equation of this particular circle. So let's first state the standard form of a circle. The standard equation of a circle states that if we have a circle whose center has the coordinate h, k and a radius of r, then we can express it in the equation form x minus h whole squared plus y minus k whole squared equals to r squared. Now in that case, we have the center. So we have the center, which is h, k, given by the coordinate 3, 4. So this immediately tells us that the value of h is going to be 3 units. The value of k is going to be 4 units. And we also have found out the radius of the circle, which came out to be 62 over 13. Now we can replace the value of h, k and r into the standard form, and that gives us the equation of the circle. So we have x minus h value is 3, whole square it. Then we have y minus k is 4, y minus 4 whole squared equals to 62 over 13 whole squared. So this is going to be the equation of the circle.